Hey everyone, here's our math problem for today. This is an algebra challenge. Let x and y be real numbers with x greater than y such that x squared times y squared plus x squared plus y squared plus 2xy is equal to 40 and xy plus x plus y is equal to 8. Find the value of x. You can pause the video and see if you can solve this algebra challenge. Now let's solve this problem together. Basically what we have here is a system of equations. So let's see what we can do to simplify this. Let's call this as equation number 1 and this is equation number 2. Let's begin with equation number 1. Notice that this part of equation number 1 can be simplified applying the converse of the power of a product, and that can be written as the quantity xy raised to the second. Notice also that x squared plus y squared plus 2xy is just a square of a binomial x plus y. We can write it like this. So x squared plus 2xy plus y squared becomes the square of the quantity x plus y. All the rest are just copied. Then let's express this in terms of the square of the binomial x plus y, and let's call this as our equation number 3, and let's remember this result. Let's go to equation number 2. Notice that we have here x plus y in equation number 3, and we have here x plus y also. But in equation number 3, that is squared. Here, there is no exponent. So what we can do is solve this for x plus y. That means we subtract xy from both sides of the equation and square both sides. We now have here the square of x plus y similar to the left side of equation number 3, and we simplify the right side as the square of 8 is 64 minus twice the product of the two terms, 8 and xy. That becomes negative 16xy and the square of xy. Let's call this as equation number 4, and let's compare now these two equations. Notice that their left sides are the same. That means the right sides of these two equations are also equal. So this 40 minus the square of xy is at the right side. This 64 minus 16xy plus the square of xy is at the left side of this equation. Then let's subtract 40 and add the square of the quantity xy so that the right side becomes 0. Then the square of xy plus the square of xy is 2 times the quantity xy squared. 64 minus 40 is 24. Copy all the rest. Now, notice that you have here xy and xy, and we can simplify this further by doing variable substitution. If we let a be equal to this xy, then this equation is written simply as 2a squared minus 16a plus 24 equals 0, which is a quadratic equation. Notice also that we can divide each of the terms by 2 to simplify this further. So we have a squared minus 8a plus 12 equals 0. And factoring now this equation using the tic-tac-toe method, a squared is a times a. This 12 is negative 6 times negative 2, because our middle term is negative. A times negative 2 is negative 2a. A times negative 6 is negative 6a. The sum of these two is negative 8a, which is exactly in the middle term. Therefore, the factors are a minus 6 and a minus 2, that is equal to the right side value of 0. So this means that each of these factors is equal to 0. So a minus 6 equals 0, a minus 2 equals 0, and solving for a equals positive 6 and a equals positive 2. But what is a? We said that a is equal to xy. So we have xy equals 6 and xy equals 2. And our goal is to find the value of x, not the value of a. So going back to equation number 2, we have here xy, and we don't know what's the value of xy. It's either 6 or 2. Now, if xy is 6, that means this is 6. X plus y is 8 minus 6, or x plus y equals 2. Now, if xy is equal to 2, if you make this 2, you have x plus y equals 8 minus 2, which is equal to 6. So we now have these two systems of equations, and let's recall the Vieta's formula. So if we have a quadratic equation, this time in terms of variable t, because we have here x plus y variables already, the Vieta's formula says that negative b over a, which is the coefficient of the squared term, is equal to the sum of the two roots, r sub 1 plus r sub 2, but that is in terms of negative b over a. That's why we have negative sign here. And since our a is 1, we do not write that denominator anymore. The constant is the product of the two roots, r sub 1 plus r sub 2. Now, if these two roots are x and y, then we can replace now this r sub 1 plus r sub 2 by this number 2, and this r sub 1 times r sub 2 by this 6, because that's the product. This 2 is the sum of the two roots. And this is a quadratic equation. Using the quadratic formula, this gives us t equals 1 plus or minus y times square root of 5, which is an imaginary number, and that is not what we want. We want real number solution for x and y. But for the second pair here, using the same reasoning, using the Vieta's formula, then this is in the form t squared minus the sum of the two roots. This time it's 6, and the product of the two roots is positive 2, and using quadratic formula, t is equal to 6 plus or minus the square root of 28 over 2, which is simplified to 6 plus or minus 2 squared of 7 over 2, which is simplified further as 3 plus or minus the square root of 7, applying the quadratic formula. So everything here is just substituting to the quadratic formula and simplifying. So we now have two roots. R sub 1 is 3 plus square root of 7, and R sub 2 is 3 minus square root of 7. Because we have here plus or minus, here is the plus, here is the minus. So which one is x, which one is y? Going back to our main problem, it says that x is greater than y. Therefore, 3 plus square root of 7, which is the greater number between these two numbers, is the x, the other one is the y value. And to check if our answer is correct using the Wolfram alpha, we substitute 3 plus square root of 7 for x and 3 minus square root of 7 for y. Using now this first equation, it's confirmed that its value is 40. Now using the second equation, using again the Wolfram alpha, we substitute 3 plus square root of 7 for x and 3 minus square root of 7 for y. Again, this equation becomes 8, which means that it's verified that our final answer is correct. So the value of x is 3 plus square root of 7.